Okay, in this segment, I want to introduce you to the drawing or the shape that you'll be using in order to conduct f-tests. As you probably know all too well at this point in time, t-tests, or more specifically, the drawing that you've been using in order to conduct t-tests involves the bell-shaped curve, right? The approximately normal shape curve. Bell-shaped, symmetrical, abscissa underneath, bell-shaped curve. The F probability distribution looks quite different. Here it is. This is what it looks like, the F probability distribution. If you're thinking to yourself, wow, that kind of looks like the right half of the T probability distribution, or that kind of looks like the right half of the Z, the normal, the completely, perfectly normal probability distribution. If you thought of that, you are correct. You're right. The F probability distribution is one-sided. There's only one side to it, and here's why. F values can only be positive. They cannot be negative. And the reason for that is because F values represent variance, a very specific type of variance. F values represent between group variance, as we've already established in previous clips. Well, variance can't be negative. The formula for variance, it's impossible for the value for variance to be negative. It can only be positive. In addition, things either vary or they don't, right? There's either some variation between the groups or there is no variation between the groups. There's no such thing as, over here on the left side of the drawing, there's no such thing as negative variance. So there is only one side to the F probability distribution, one side, which also means there's no such thing as a one-tailed or a two-tailed test. There is only an f-test, and so there's only a tailed test. So we're going to go over this in some detail later on, but here's another rendering of the F probability distribution. So if you want to practice drawing that in order to make sure that your work is as neat as possible, you can go ahead and do that. And another thing that you're going to have to do with every single f-test that you conduct is to indicate a tail. And again, there is no one-tailed or two-tailed test. There's just a tailed test. So that's how you would indicate the tail. Although, boy, that's not very straight, is it? Here, maybe if I hold it like that. It's not very straight. And also, the other thing you're going to have to do is indicate whether or not, indicate the size of the tail, and I also want you to indicate the size of the body as well. You may recall in a previous clip that they're using the material that's available in SPATS. There are only you can only conduct either a test at the 0.05 level or the 0.01 level. All right, there are no other options, as we'll see in a little bit. So you'll either be testing hypotheses using f-tests. You'll either be testing hypotheses at the 0.05 level or the 0.01 level. Now, I've already demonstrated how to set up the probability distribution. If you're conducting a test of the hypothesis at the 0.05 level, then your tail, that's the size of your tail, 0.05. If it were expressed as a percentage, it would be 5%. But since we're dealing with probability distributions, I'm expressing it as a proportion, 0.05, which means the remainder is 0.95. So despite this kind of funky shape, relative to the t-distribution or relative to the normal curve, despite this funky shape, the entirety of the probability distribution is 1, or 100%. 0.95 plus 0.05 is 1. All of it, the whole thing, 100%. So that's what the probability distribution would look like if we were setting up a problem to test at the 0.05 level. One thing that's missing, and we haven't talked about the table yet, so I'm not going to fill it in, but one thing that's missing is an F value from the table. All right, and we'll talk in a little bit about where or how to find the correct value. But this is, again, this drawing, this is the F probability distribution, and this is how you would set things up if you were asked to test a hypothesis at the 0.05 level. Draw the F probability distribution just like this picture. Here's a non-marked up version. Draw the picture, indicate a tail, indicate the size of the tail, indicate the size of the remainder, and then indicate the F value from the table, which again we haven't gone over that yet. If you were asked to conduct an F test or test a hypothesis using ANOVA at the 0.01 level, gosh, it's a terrible drawing, pardon me, I can do better than that. Draw the F probability distribution like that. Indicate a tail like that. In this case, in theory, pretend we've been asked to test a hypothesis at the 0.01 level. So that is the size of our tail. Indicate the size of the body. And then last but not least, indicate the appropriate F value from the F probability distribution from the F table in SPATS. Okay, so that is a little segment on how to set up the drawing, and again we'll revisit this later on as well.